So just watch this. Do not worry about writing this down. So what happens usually is if you have, for example, the integrand of 1 over x, most students, what they will do is they'll say, okay, well, in differential calculus, what we did is we moved the x into the numerator, so it became x to the -1 and then our dx. All right, so then if I'm going to integrate x to the -1, what I need to do is I need to add 1 to the exponent and then of course divide by that new exponent. Now you'll notice that when I do that, I lose the integral sign, I lose the dx, but when I go through that process of adding 1 to the exponent, dividing 1 by the new exponent, I get x to the -1 plus 1 over dividing by the new exponent will give us a 0 in the denominator. And as we know, we cannot have a 0 in the denominator. That is a no-go. So it's an undefined expression. So what that tells us is the power rule doesn't work if the power is equal to -1. So the power rule only works when the power p is not equal to -1. And I specifically did not make a big deal about this when I was covering this in the video, but there is this little statement when you look at the power rule that the power has to not be equal to -1. So the question, of course, is, well, how can I integrate 1 over x since the power rule does not work for me? So that is where we are going to need to use our understanding of derivative integral connection. Because remember that the derivative of natural log of x was 1 over x. So if I integrate 1 over x dx, that by this connection between derivatives and integrals should give us the natural log of x. Now, there's one little hiccup here, and this is an important part of this. Remember that the domain of the natural log is that the argument x has to be greater than 0. So when you're just looking at 1 over x integrand, there's nothing there that says that the x value is positive, right? X could be anything. Now, we do know that x is not equal to 0 because x is in the denominator, but we do not have anything there to ensure that we have a positive argument. So what we need to do to add on to this definition is we need to make sure that this natural logs argument is defined for an appropriate domain. And so for that reason, we are going to use absolute values to ensure that we have a positive argument. So the definition or the rule that we're going to have here is this 1 over x integrate dx goes to natural log x plus c. Now, it's not just natural log x, it is the absolute value of x, and that is to ensure that this domain is satisfied. It's to ensure that the argument is in fact positive. Now, I want to just tell you one thing about this. This is a beautiful rule, this 1 over x dx, but here is how I usually think about this. I think about if I see x to the first in the denominator, that is going to go to natural log absolute value x. So I'm not really so focused on like the 1 over x part. I'm focused on the x to the first in the denominator. That's going to tell me that it's going to go to this natural log absolute value x. So if you look at this example 3 over x here, really the telltale is this x to the first in the denominator. Now there is a question of, well, what do you do with the 3? So before I say anything about this, I want you to try to see what you would think at first glance the integral of 3 over x dx is, and then we'll talk about it in the next video.